Okay, this is just a little bit more about rational exponents. Sometimes rational exponents can be a bit challenging. Problems such as this one requires us to use rules of exponents we may know from the past, combined with some newer knowledge regarding rational exponents. So let's walk through this step by step. Since we have a fraction, I'd like to focus on whether we can do any cleanup in the numerator and or denominator. So let's focus for starters on this first piece, a squared times b to the fifth, that quantity raised to the power of negative 1/4. Using the rules of exponents that say a power raised to a power requires multiplication, we're basically going to need to simplify this by saying we really have a squared being raised to the power of negative 1/4, as well as b to the fifth being raised to the power of negative 1/4. So when we have a quantity being raised to a power, that power is applying to each part of the quantity, and then in this case that really ends up looking like power raised to power for each a and b piece. Similarly, we will do some work in the denominator. So if you'd like to focus with me on that for a minute, the situation down here is quite similar to what we just did. In the numerator, we gave the power of 1/4 to the a and the b terms. So similarly, you can see that the a and the b terms in the denominator will each need to be raised to the power of 1/6. That means I'll have a to the negative 3 being raised to the power of 1/6, and then I'll have b squared being raised to the power of 1/6. So although it maybe looks a little worse right now, we're going to clean up for a bit and see what we have. This is where you may choose to do a little bit of side work to clean up. I'll just kind of talk through each piece. When I have a squared raised to the power of negative 1/4, I need to multiply 2 and negative 1/4. I'll think about 2 as 2 over 1. I could multiply straight across and get negative 2/4, or some of you may have cross-canceled. Either way, it reduces down to negative 1/2. So here's some side work to show that the new power on a in the numerator is negative 1/2. Let's do the same thing for our b term in the numerator. We can see there it's b to the fifth raised to the power of negative 1/4. So 5 times negative 1/4 is really 5 over 1 times negative 1 over 4, which would be negative 5 over 4. It doesn't reduce. So that would be the new exponent on our b term in the numerator. Let's focus now on the denominator. Let's see if I can find another color here. So if we work on a to the negative 3 raised to the power of 1/6, I'm going to need to multiply negative 3 and 1 over 6. I'll write negative 3 as negative 3 over 1. Multiplying straight across, I get negative 3 over 6, or you may have cross-canceled, but either way we'll come up with negative 1/2. So this will be the new power on a when a is in the denominator. So I'll have a to the power of negative 1/2. We're so close, we just have one piece left to work on in terms of cleaning up the numerator and denominator, and that is this b squared to the power of 1/6. So 2 times 1/6, it's really 2 over 1, times 1 over 6. So 2/6 or 1/3. So the new power on our b term in the denominator is going to be 1/3. All right, so I hope you're with me so far. This was a lot of work to get to this point, but again, what we've done is we've cleaned up the top of the fraction and the bottom of the fraction somewhat basically independently, right? We were able to work them independently. Now is when we need to start considering how do we clean up top to bottom. So let's talk about these a terms. You'll notice that I have a to the negative 1/2 divided by a to the negative 1/2, and anything divided by itself just simplifies to 1. So that part wasn't too bad. Now to tackle the b terms, when we are dividing, what do we do with the exponents? So we would actually be subtracting the exponents. So to continue on here, my next step will be that the power on our b term will be whatever negative 5 over 4 minus 1/3 is. So I'm getting a little tight on space. We'll try to fit it in. If I'm doing negative 5/4 minus 1/3, the least common denominator between those two terms would be 12. So on the side here, I'm just going to show that I would need to multiply the 4 by 3, top and bottom. And then I would need to multiply the 3 by 4, and in the numerator as well. All right, so cleaning that up, we get negative 15/12 minus 4/12, which combines to negative 19/12. So that was my side work to show that the new power on B is the same as negative 19/12. Typically with these types of problems, the directions will say to write your answer using positive exponents only. So we are one step away. Because the exponent is negative, we can make the exponent positive by moving it to the denominator. So 1 divided by b to the power of 19 over 12, if you can read that, let me try again, will be our final answer. So 1 over b to the 19 over 12 power. And that's it. So rules of exponents combined with rational exponents can be a little interesting. Have fun.